Homework 2, problem 1. This question gives us a kind of picture that it shows the signal x1, enter the noisy channel to be x2, and finally the xk. Is a number that we don't know, and enters the noisy channel and becomes xk plus 1. Okay, it has 4 questions. The first one is that we need to find the probability that x2 equals to 1. So according to the condition, we have this the probability that x2 equals to 1 with the condition that x1 equals to 1 is 0.7. So we can use this to calculate that the probability that x2 equals to 1 and x1 equals to 1 is 0.56. That's the probability. Okay, so now we got this. The probability that x2 equals to 1 with the condition that x1 equals to 0 is 0.4. So with this, we can get the probability that x2 equals to 1 and x1 equals to 0 is 0.08. So we know that the whole condition with x2 equals 1 is that because the probability that x1 equals to 1 and the probability that x1 equals to 0, they add together is equals to 1. So these two guys add to each other means is equal to the whole condition that the x2 equals to 1. So the probability that x2 equals to 1 is these two, the sum of these two guys. So the result is 0.64. That's the whole thing. So that's the question 1. And the question 2 is we need to find the probability that x3 equals to 1. So in the condition, we know that so according to the first condition, we know that the probability that x2 equals to 0 is 1 minus 0.64. So this probability is equal to 0.36. So according to the condition, the probability that xk equals to 1 with the condition that xk minus 1 is 1, minus 1 equals to 1 is 0.7, and another thing is 0.4 according to condition. So we can use another way to calculate the result. According to the question 1, we know that the probability that x3 equals to 1 is the sum of these two guys. So but they have another these two guys, so we can calculate in this way that this probability multiple 0.64. This is the probability that x2 equals to 1, and this multiples the 0.36. That's the probability that x2 equals to 0. So the sum of this is the whole things that x3 equals to 1. So the probability is 0.592. It's the approximate result. Okay, that's the question 2. So now we enter question 3. Question 3 need us to calculate the probability that x1 equals to 0 with the condition that x3 equals to 1. It's a totally different thing. So we can use this way. From A and B, we can get that. We can use this. It's a matrix. It's a kind of matrix. P, the probability xk plus 1 equals to 0, and the probability that xk plus 1 equals to 1. It's kind of this thing. That's the whole matrix. We can use this matrix to calculate the result. Okay, so for this question, we need to calculate the probability x3 equals to 0, and the probability that x3 equals to 1. So we can use this, that we after we calculate with the basic condition, we got this. And also we use this to get this. Okay, so the question is, we need to calculate this, the second one. So we use this to calculate this, and after I calculate, I got the result, the matrix that 0.48, 0.52, 0.39, and 0.61. So according to question, we need to get the second one. So the result is 0.52. That's question 3. Okay, the final question, we need to find the probability that xm equals to 0, and m is approximate to the very large number. We don't know. Okay, it's a positive number. So we can use this. We let the probability x we let the probability of this to be a small p, and this, of course, 1 minus p. So for m, m approach to the very large number, we can use the matrix we used in the last question, in the third question. So because it's approach to the very large number, so for this multiple this matrix is also approaching this number, because the number is very large, so it's actually approximately the same. So we use this to calculate the p, and we got this, and finally we got p is equal to 3/7. So therefore the result is this. So that's the final question. That's the whole thing about the problem 1.